Hello, Internet. My name is John Kulas. I am a 20-year professor of industrial and organizational psychology. I'm a 10-year user of R for statistical applications. And for the last 6 or 7 years, I've also been using R to author things like technical reports and feedback reports and academic papers and slide decks like the one you're looking at right now. So every week I get together with some compatriots here who are also interested in using R to author things, and we just hold these open office hours and make ourselves available to anyone who may stumble across this and may have a question regarding how to author things in R. So there's lots of static tutorials on YouTube. YouTube is great for those to learn, but there aren't many interactive opportunities. And so we wanted to hold these open office hours at a standard time. And if people have any questions and puzzlements, they can pop by and just pose them. Today, I kind of ran into an issue that would be good to kind of bounce ideas off of someone. Uh, Occasionally, the name of your file or the name of folders that you use with these authoring projects is important.
Vamos a ver, ¿qué es lo que pasa con los alcaldes? ¿Qué es lo que pasa con los alcaldes? ¿Qué es lo que sí, qué está pasando con los alcaldes?
Hey, hello.
Hey, Diego. So I was just talking about something that I ran into today that's consistent with this idea of having these open office hours where someone can just drop by and kind of bounce ideas off of other people. You know how sometimes what we name things is important? Usually it's not, but sometimes it is. For example, when we're publishing our shiny dashboards, depending on where we're putting it, the destination, it's important that we call the source file app, right? APP.
Yeah.
That's something that you and I have come across. Similarly, hosting on many of these free platforms that we use, you want your source file to be named index. Well, today I was having a problem. I was having a problem calling up images on a dashboard or one image on a dashboard that was saved locally. So I could put up any picture I wanted from the internet. So of course, because this is what I do, I had a picture of like the Pink Panther on my dashboard, but I needed an actual organization specific icon, and I couldn't get it from my local computer, even though I could just grab some random image from the web. And so it turned out that using Quarto dashboard, there must be something baked in where it wants the folder where you store those images. It actually wants it to be called images, and that sounds trivial, but there are little things like that. So anyway, so every week we hold these open office hours. If anyone has any troubling issues or any sort of puzzling things that they come across, they can pop in and ask us, and that's what we're here to help with. And I think I said this last week too, but it seems like more people are utilizing these sessions after the open window. So it's not during open office hours, but people are kind of stumbling across it from the feedback I see on my end. People are seeing and accessing these videos during the week. And so that's fine. If you see it if you stumble across this during the week and happen to have a question, an issue that you want and brains on, I think you can leave a comment or drop one of us a note, and we can try to address it next week. So every week what we do is we revisit what happened the previous week, and then unless there's someone that has a pressing issue that we want to collectively problem solve, we've been going over these, kind of just walking through different different features of the authoring options within R. And what I'm stalling with right here is I forgot to put the slide deck in the comments, so I'm putting it in the comments now. There it is. So anyone that stumbles across this has access also to these slides. And tonight, what we're going to do, and I think hopefully Diego's going to maybe take the lead on it, or we can just tackle it together, is we're going to take a look at this quantitative analytical concept called exploratory graph analysis. And this is new to me. I don't, Diego, have you had the chance to play with it at all?
Yeah,
Or,
I went through the example on the website from
okay.
the guy's name is what was it? Um, it was Hudson Golino.
Galino, yeah. Are you familiar with that? I think it might be Portuguese. So I think he's in Brazil, or he's from Brazil, I think.
Yeah, I think he went to university there.
Did you see that the other person involved with that is Sasha Epskamp, the Semplot person? You were just dissing on Semplot the other week, and and
Same person. Oh boy.
yeah, well, yeah, I'm pretty sure it's the same person. All right, let's do a quick transition here into what happened last week.
Well, the good citizens of Pottsylvania are extending Rocky and Bullwinkle a real Pottsylvanian welcome. For Boris and Natasha disguised our heroes as, guess who? Boris and Natasha. Then, under orders from Central Control, the boys have been arrested and hustled toward a sinister platform.
Hop,
But you don't understand. We're friendly.
we're not. Hop,
Come on, Bullwinkle.
where are we going?
You heard the man. Up!
Meanwhile, the real Boris and Natasha had escaped from the ship and made their way through the city to the underground headquarters of Central Control.
They fixed up the place since I was here last. You, fearless leader, where are you?
Right behind you, Benino.
11, 12, 13 steps. Rocky, that's liable to bring bad luck if we're not careful.
I love it when Rocky says we're friendly and the guy says we're not. It's such a good response. So Diego, if something happens here and you want to jump in, just jump in. But the last 2 weeks, and this is why we're looking at exploratory graph analyses tonight. It's the first real quantitative thing that we've looked at during these weekly sessions, actually. But it's related.
Mostly it's been reporting and
Yeah,
APIs.
yep, yep. But it's related to what we were doing the last few weeks because we've been focused on these diagrams. And it looks like the focus of exploratory graph analysis is also at least visual. It does it. I think we could categorize it as or characterize it as a diagram. We looked at Mermaid 2 weeks ago, and then last week we looked at GraphViz, which is another type of, I don't know if we want to call it a language or a platform, but it's a capability that's built into Quarto where we can make our own chunks, just like we do an R chunk or a Python chunk. We can make a Mermaid chunk or a GraphViz chunk, and using their syntax, we can create these nice visuals. Now, one of the things that Diego, we were noticing across GraphViz was the GraphViz objects are complex in terms of the information you get upon hover. Now, it's difficult to see on my screen. Hopefully it's a little blown up on other screens, but this image that's being produced here on the right from the syntax on the left, first of all, if I hover over the white space, I just see the title. Here we called it Unix. But if I hover over these individual elements, I also get information about those elements. So 5th edition here, I get 6th edition, I get 32V. That's different from what we get from the Mermaid produced diagrams. And so that to me is a real differentiating feature across these. The syntax itself, and I only pulled up a few that we looked at last week. I didn't pull up exhaustive examples, and I also tweaked these a little bit. So this was when we went over it. It was a really bigger image, and there was more skew on these polygons. So if you look at the syntax here, they're permitting distortion, orientation, and skew for all of these polygons. Now, the main feature that we saw was the sides. And so you can see for this fifth edition element that's on the top, we just specified 3 sides with no skew, no distortion. And the orientation is also set in terms of 360 degrees, I believe is the scale. It's just set at 0. So it's a triangle that's not on its head. If we were to change that to 180, we'll try that and see what happens, see if it flips it on its head. And then, so there's kind of, there's a sequence of scripting that defines the nodes themselves, those shapes. And then underneath that, there's just a series of what's connected to what. And so again, this is very similar to the flow chart that we actually saw. If we were to go ahead and let's invert that. Let's see if we can get the 5th edition object. Let's see if we can actually twist that so the point is going down. I haven't tried this, so I don't know if it actually works. And I'm not sure if the orientation field is 360 or if it's something else. We can see the effect of it here if I just change it from 3 sides to 5 sides and then re-render this. You should see it in my preview window here. And so you can see a hexagon there. We'll change it back to 3 and we'll try that. Let's try 180 and see if it takes it as a value. And again, Diego and I, as we were going through this, we didn't really read the documentation. We just, yeah, it is. So it is a full 360. So that 180 completely inverts it. The skew, you can see like this PWB object here. Let's see if we wanted to, here it's currently got 8 sides. It's on line 82. It's got 8 sides. It's goldenrod 2 in terms of a color. We could change the color. I really prefer, I've gotten used to those hexadecimal codes as opposed to descriptive labels. Little distortion and skew to it. We'll change all those to 0. And we can see what a normal 8-sided stop sign looks like. Oh, we could call it stop too. Let's do that. So the orientation, again, that's twisting of it. I'm going to set it straight so nobody hit the doggone. Oops, I'm on the wrong one. Did I say line 82? Yeah, I went down to mini Unix. Sorry. So I went down to this quadrilateral here, this kind of cyan colored quadrilateral. But what I wanted to do was this PWB 1.0. We'll go ahead and change that to a red stop sign. And because this isn't linked to anything, there's nothing coming from PWB. There's only something going to it. It's not going to hurt anything. We'll call it stop, like a stop sign. I'm going to look down here for PWB on line 96. I see 5th edition going to it, so I'm just going to change. I'm going to keep that line, that arrow going to it, so I got to stay consistent there. And so you can see the syntax here for these diagrams is actually pretty straightforward. You can see what happened there to that object just based on my changing. Here it's on line 18 in the slide instead of the larger, what we were working on with 80s and 90s. That's the entire slide deck with all of these different, with everything in it for this week. If we just isolate to what's creating this diagram here, we now are on line 18 and we see the 8-sided red colored object that is only being fed by 5th edition. So the syntax is actually pretty straightforward and intuitive. We looked at cluster objects as well. And so this also was fairly intuitive in terms of, I didn't try changing the font. I think it's, for today, the font isn't too many spaces for me to really play with it. Did we play with font last week? I don't remember. We played with all kinds of stuff. The thing that was, again, the syntax is fairly straightforward in terms of relationship among objects. The thing that we thought was neat was on lines 28 and 29 here, the shapes of these beginning and ending objects, they're just intuitive. So I changed it. I just put an oval in there just to see if it would work. originally it wasn't oval, it was M something or other. I don't even know what it was. But if we just put, what, triangle? I'm going to try that and see if it works. So we're looking for this, what's labeled start, to be a triangle. And again, it's fairly intuitive. So we're just putting in kind of everyday colloquial terms or everyday language concepts, and that seems to work quite well. Last week I think we went up to dodecagon, right, Diego? But
Yeah.
we can try pentagon or hexagon. We can change the name of this. It doesn't need to be start. It can be Diego, and we just want to make sure to be consistent up here in terms of the flow itself, these elements. I'm not sure why I'm getting the color feedback. The it may it's likely that that's not too informative. There's Diego and a hexagon. It's likely that the color feedback I'm getting in my R environment is not that informative because this is not an R chunk. It's a graph viz chunk, which is identified by this DOT, Department of Transportation sounding thing. So that's a cluster analysis, again, fairly intuitive. And then we add a color gradient as well. And so that's just upper right to lower left in this particular graph, going from red to green. Sorry if you're colorblind. And I don't know, it looks like a bingo chart. So we just kind of played around. I think the take home from the last 2 weeks is that the mermaid graphs render nicely for things like slide decks or HTML files where you may want to see through the background. So we had transparent backgrounds by default on the mermaid images. The graph viz diagrams, it seemed like there was maybe just a little more built into the system, ease of what we normally would control with CSS. So those cascading style sheets are ways to control the way images and pictures and fonts and things look rendered in an HTML file. The graph viz seems to have more CSS type customizations kind of built into the syntax. And then again, the other thing is the just specificity of these different elements. If you were to want to maintain the individual elements as individual elements within your diagram, then the graph seems like probably the way you actually want to go, because we are getting customized, specified feedback based on these individual elements that are in this fairly complex object here that we created. Okay, so today I think what we're going to do, and Diego, I actually, as we take a look at these exploratory graph analyses and see if we can get another kind of pretty funky diagram in our document, whatever it is that we're trying to write up or document. I shared with you, Diego, and I sent you an email, but I think one of the files might have been too big. So I actually shared with you a Google spreadsheet of some
No, I
data.
have the IPEEP
Oh, okay. Yeah, so
and the
when
Neo.
okay, awesome. So we're going to be looking at this exploratory graph analysis, which seems to be a newer. So the article that I saw, Diego, was 2017. I think I have it open here. So 2017, I was just taking a look at this to get a little background on this. And so in 2017, they talked about a new approach, which means that they probably started kicking this around 2010 or so. And they compared this new approach, this graphical approach, to some pre-existing methods that are typical in psychology to help inform the number of dimensions that are underlying responses to things like psychological assessments. And so this isn't all, well, I don't know. I guess we'll find out how different it is from some of the existing methods. One thing, Diego, that I was curious about, and I should have read it a little more carefully, But I was curious if this method was more consistent with a true factor analysis, or, oh, by the way, if you're stumbling across this, everything we've done so far, and this is, we started in December of 23. We've gone every week. Have we missed a week, Diego? I don't think we missed any week, did we? I think we've gone every week.
Only the one where you went to PSYOP.
Yeah, but we still did it because you did it then, right?
Yep.
So we've done every single week, and we have not done anything quantitative or data analysis related. So today we're actually going to be doing some data analyses, but it's so similar, it's so much, it's so heavily related to the last couple of weeks. I think it's kind of fun, and it'll be, I don't know, it'll be neat getting back into some analyses. Diego, one of the things I saw with the documentation was that they were using the BFI, right? The Big Five index.
Yeah.
And so I think you'll probably start with that, but then I also sent you a couple of data files that I had. So anyone that stumbles across this, Diego and I are both industrial and organizational psychologists. We both have strong interest in issues of psychological assessment and measurement. And there's a divergence in assessment between inventories and tests. And a test is something that can be scored correct or incorrect, and an inventory is something that can't or typically is not scored correct or incorrect. There are scaled responses most typically to inventories. And so the BFI, the Big Five Index, is a measure of a psychological framework of personality. And that psychological framework is the five-factor model or the Big Five model. And so the Big Five model, when someone like Diego or I sees a graph like this one, we say, ooh, that's Big Five. And we can tell right away just because of the letters. So the letters have an acronym. I like the acronym OCEAN, but my students like the acronym CANOE. Whether you have OCEAN or CANOE, we have five theoretically specified personological or personality dimensions here. Conscientiousness, well, we'll do CANOE. So C stands for conscientiousness, A stands for agreeableness, N stands for neuroticism, O is openness to experience, and E is extroversion. And so for many, 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 many years, this is kind of a, I don't know how to frame it. It's not universally loved and it's not universally embraced, but it's widely considered to be a structure that can be informative with regard to individual differences across people. I guess that's a political way to put it. And so I think Diego will probably walk us through what the BFI looks like. And the BFI is a canned data set. The BFI data set is contained within the psych package, which is maintained by a personality psychologist, William Ravel. And Ravel has all kinds of data sets, I'm sure, with personality data. I have all kinds of data sets, I'm sure, with personality data. And previously, when I went off on a tangent about doing analyses and talking about Diego and I and our background, one of the things I meant to say was that I have years and years and years of personality data that's been anonymized. So it's been stripped of any sort of identifying characteristics within it. And so we'll take a look at BFI, I'm sure, but then we'll also take a look at some data that represents two different five-factor model measures. So all three of these data sets that we're looking at are purported to measure five main things. And we could quibble about that and have a whole probably Tuesday session just on what's there and what should be there and the level of abstraction that is important and informative with personality information. But so we have the BFI, which is a measure. We have data from that. It's purported to be informative with regard to five personality traits. The NEO is another measure of the five-factor model. Then the NEO, there's different versions of NEO FFM. There's NEO PI and PIR, and these are all measures that are intended to aggregate also to those 5 traits: conscientiousness, openness to experience, neuroticism, extroversion, and agreeableness. I probably screwed that up, but there's 5 things there. So we have the BFI, we have the NEO, and then we also have the IPIP. And so instead of mixing it up with intelligence data and personality data, and maybe personality data from different theoretical frameworks of personality, because there are different theoretical specifications of what personality is, I thought it would be maybe neat to try data that comes from 3 different measures of purportedly the same 5 things. And so the IPIP is the third data set that we have, and the IPIP is an acronym. It stands for International Personality Item Pool. And so the International Personality Item Pool, at one point, it had 2,713 different items that were intended to be indicators of different personality characteristics. The IPIP form that we have, that we'll probably take a look at, is intended to measure the 5-factor model, or 5 things at the highest level of abstraction or aggregation. And so I think we probably have 3 different data sets that we can take a look at, right, Diego?
Yeah, but I think we might need a key
Yeah. Well,
to map it.
very good point. So one of the things I'm curious to see is what this exploratory graph analysis looks like with and without reflection. So with and without reverse scoring. Because theoretically, and again, I think I cut, but question of whether analysis is directly applicable to a true factor analysis or a principal components analysis. Now, those 2 procedures tend to end up with very similar kind of conclusions. But there is a technical difference between those 2 procedures, and it's basically what you analyze. Am I analyzing all item variants or only shared item variants? And when in the documentation that I saw, the package authors were talking about partial correlations that they use. And so if they're using partial correlations, that is most directly analogous to a true factor analysis as opposed to a principal components analysis. The distinction there is probably not that important for our current purposes. But I think this is, from what I see, from my skimming of not just the tutorial on EGA, but also the source kind of introduction of it, the academic introduction of this procedure. It looks to me like it's probably more analogous to or more applicable for a factor analysis than it is for a principal components analysis. Okay, Diego,
Okay, I'll share screen.
yeah. Okay, this is exciting. Can you blow that up a little bit, Diego?
Yep.
I'm gonna move you over so I can see it too. So by the way, so you mentioned key. Do you want me, while you're kind of walking through this, Diego, do you want me to develop a key for those other data sets, or do you think we'll just spend the rest of the time on this data set?
Well, I'm not exactly sure what the key is supposed to look like. This is the dictionary that they're using, and well, I'll go over the example. But what the example looks like is this.
Okay, because I know that the BFI data, if you're getting that from the psych package, that should be raw data. So that also needs to be recoded. And so if anyone watches this and you're not familiar with psychological assessment, particularly with inventories, it's very common for psychologists, even though we measure neuroticism, the keying of the questions oftentimes flip-flops. So these dimensions are kind of bipolar. So we have extroversion on one end and introversion on the other. We have neuroticism on one end and emotional stability on the other. And so when you're administered psychological assessment indicators or questions, they're not all neuroticism questions. Some of them are emotional stability questions. And so prior to scale level aggregation, prior to actually giving you a score on neuroticism, we have to go in there and do a little tweaking on some of the items. And that's what we're referring to when we talk about reflection or reverse coding. So that simply means prior to scale level aggregation, typically people like Diego and I, we go into the data and we take the raw responses, and for some items, for some responses, we'll actually reflect them such that an answer of strongly agree is keyed as strongly disagree. So if you strongly agree with a emotional stability item, the thought is that you're going to strongly disagree with neuroticism indicator. And so we go in there and do that. And so Diego, when he's asking about key, the scoring key, he's asking about what someone like Diego and I is typically communicated when we're given assessment data. And that's not just the data, but it's also a code book that says item 1 is okay, item 2 you should reflect, item 3 and 4 and 5 are okay, item 6 you should reflect. And so Diego, with the IPIP data, I think the IPIP data that I gave you was probably a big data set, or you already loaded it in?
Yeah. This one,
Yeah,
almost 21,000.
yeah. Okay,
So I
so
think,
but
there we go. Actually, it's, what is this?
oh, that's interesting. That looks like it's from the BFI. So
Yeah.
okay. So Diego, maybe kind of can you talk us through, maybe just go from the top to the bottom, or we can build something. And I'm behind on this, but I do want to cut some of these up because I think when we, you know, until people come in and they have questions about how to author with R, as we keep doing these little walkthroughs, these little tutorials, I think it's probably more digestible if I cut them up. So if you talk through what you're doing, it's going to be easier for me to cut it up later and then present it and other people can access it.
Oh, okay.
And by the way, as you do that, I think I will go I think I will go in and try to get you a key, at least for the NEO data, because that's a smaller data set. The IPIP file I sent you is probably too big. But the NEO data, I think that's a NEO FFM, which means it's a 60 item measure. So I should be able to get you a key on that. So I'm going to be quiet for a while you walk through that, walk and talk through that, and I'm going to develop a key for you.
So the first is just to load the packages. The package is called EGA.net, and then also the Psych Tools package. This is just to load the BFI dataset, and the BFI dataset looks like this. Let's just load it there just so people can see. Here, it's taking a while. There we go. So it's A's for agreeableness, C's for conscientiousness, E's for extroversion, and for neuroticism, and O for openness. And then at the end here, it has three, gender, education, and age, which the code just ignores it. And then they're all on a Likert scale of 1 to 5. It's 1 to 5, or 1 to 6, I mean. So the first thing that they suggest doing here is to determine redundancies. So this part of the code is just looking at those items that have high local dependence and removing them. So if we run that, and we just the function that takes care of this is called UVA, and then inside that we just put our data, which is going to be the BFA from column 1 to 25, and it's 1 to 25 because the last three are just demographic information, not item information. You can only put item information in there, and then this one I think is the actual content of the items, and I think it's just there, so whenever it shows up which items it removes, you know exactly which item it is. Otherwise, it just shows you the column name. So let's print those results. I don't know why it's taking so long. Something running in the background. Maybe because of the plot. I'm going to remove the plots.
I got myself muted too, Diego, while I'm sitting here and typing, so my keyboard doesn't come through. So if you need anything, just make note of it or say something. I'm half paying attention to you, and I'm half doing this.
Okay, let's reboot R.
That's
There we
always a good
go.
idea. I had to reboot my whole laptop this morning twice. Um, it was I think it's time for a new laptop. It was actually disconnecting, not disconnecting, but like really slow in terms of the network. Um, I don't know what's on that thing, but
So
restarting R is also a good idea because, especially when you get your environment cluttered with objects. All right, I almost got this ready for us to. Whoops! What did I do? I did something wrong here too.
well, so here it is, the object, or UVA object, which stands for, what was it? Unique variable analysis. And he uses this metric called weighted topological overlap, which I'm not really sure what it is, but everything that's above 0.25 uh, eh, indicate that they're highly redundant, and the code removes it. The UVA function removes it, and then you can access to see which one is removing. So first, it gives you a summary of this metric for your items, and then you can access more information with the $sign, like the items that it kept and the items that it removed. And because it has this key here with the content of the item, it shows you what the item is. Like the one that it kept was get irritated easily. The one it removed was get angry easily. If we didn't have this, it would just show us the column name to be whatever item it is. And now here is to graph. The EGA function is to actually create the graph. So let's do that. And there we have it.
Well, it's pretty. Do we know what it means?
Not much. It seems factor analysis, everything that's clustering and showing the relationships between the different factors in our data.
Well, okay, so one of the things I guess is the distance between the nodes. So I did see in there, they did a bunch of simulations. And so they mentioned with their simulations that, uh, they mentioned with their simulations that their procedure might outperform some of the traditional uh, identifying dimensionality within a questionnaire. They might perform some of those traditional methods when the scales themselves, I don't know if they use the word scale or latent or construct, but when the uh, dimensions, I guess we can call them, when they have a fairly high correlation among each other. Now, theoretically, the five factor model is completely orthogonal. The constructs are orthogonal. What we mean by that is knowing how extroverted you are should tell me nothing about how neurotic you are. Uh, it, it's a problem that we've had in psychological measurement since we started trying to measure these things. Theoretically, there's no association or no information that is gained by knowing someone's score standing on one psychological dimension in terms of information gained on a second or third or fourth or fifth psychological personality dimension. Now, with the measures, unfortunately to theorists, the measures are always moderately correlated. So, according to the authors of this procedure, their procedure does is maybe perhaps most incrementally informative and useful under those circumstances where we have moderate to even what probably would be considered high associations among those latent scores or those latent factors or those dimensions or those scale scores, those aggregate scores. The number that I saw in one of the simulations was 0.7, which I would characterize as a high association. So Diego, one of the things I was curious about is the positioning of a cluster versus another. Now, do we know why one of them is on the right and the other is far to the left? Does that indicate less of an association? Because typically when we look at a network like this, the nodes, either the node thickness or the distance of it is intentional. So that's meant to convey some information. Do we know if that's taking place with this or not? And by the way, did you do any recoding on the BFI?
Recoding? No.
So let's do a quick alpha analysis of maybe just like the agreeableness items in that data set. So that's the psych package.
No.
And so what Diego and I are doing right now is we're checking to see. I think, Diego, we don't need to go row, comma, column on this. It should just be without comma. We should be able to do concatenate. Because I'm doing it right now too. I forgot the actual script, but I'm doing it right now too. So then, yeah, in parentheses, it's like it should be 1 through 5. I think they're in order. So all the agreeableness items should be there. And so what Diego and I are looking at is we're looking at the R drop there on the item statistics. And so that's informative to psychological assessment individuals like us, because the concept of reflection or reverse scoring that we were talking about will oftentimes pop with that particular statistic. And it does here. So this is telling us that A1 should have been reflected. Now look at A1's position there. It's grouped correctly. It's in with the other A's, but I wonder if its position there at the bottom means anything. Because look at the node, Diego. Can you pop that up? There is some color information in there. So it looks to me like it's red.
The line, yeah, the line is red.
So that probably is telling us that that should be reverse scored, right? So
yeah, this should be probably also this one, extroversion. Um,
But it gets more complex, right? When there's more than one that should be reflected on the same scale, especially when there's only five total items on the scale. Like agreeableness, we can see A1 is the only one among those 2, 3, 4, and 5. 2, 3, 4, and 5 all have green. A1 has looks like universally red going from it. Now, is the association between A1 and A5 really weak? Because we don't really see anything. Can you do a correlation A1, A5, Diego? Let's see if that's really small.
sure. Okay, A1 and A5. Oh,
U's equals, I think.
so
Okay.
negative 0.18.
Yeah, it's pretty small. But if you look at A1 and A2, because that node is pretty wide, right? So we're assuming that that node, even though it's negative, it should be, fairly high.
0.34.
Okay, there we go. How about, let's look at the widest nodes we have. N2 and N3, that looks like the widest, doesn't it? The nodes are closest and the linkage is widest. So it looks to me like that's probably one of our. Diego, you got to like this data set because you like using caps lock so much, and these are all, they use capital letters.
Yeah,
Yeah.
0.54.
Okay, and I would think that's probably one of our biggest correlations in there. So this is interesting though. So this is telling us that the procedure probably doesn't require, which is great. One of the problems with all these factor analytic, well, I don't want to go there, but it's great to actually not need to go in and reflect prior to getting some feedback about what the structure might actually be. Do you want to reflect A1, Diego, and see what that chart looks like? And then I'm gonna just quickly here, I'm gonna do a recode for you on the NEO. I got sidetracked, so I'm only through one of the scales. And I'm doing the same thing we did. I'm just looking at the R drops, the corrected item total correlations. And if anyone happens to stumble across this, this is not the way you're supposed to identify scoring keys. But Diego and I, we've been doing this for a while, so it's kind of a trick.
It'll be like this, right? Absolute value of -7. So if it's 2, it's going to be, yeah.
Oh, this is also good. This is a good demonstration, I guess, of the importance of scripting. So we would, if Diego and I were doing this for real, we would be doing it in the script itself, so we have a record of what we've done. It's really easy to accidentally reverse score twice, so you undo what you did. So when you're in the console or when you're using pull down menus in a different statistical platform, something like, for example, SPSS, it's very easy to make a mistake that you don't realize you made if you don't script. So I don't actually need to come up with this key, but I'm gonna identify it here, and then we can see if it matches with your analysis as well.
There we go. Now it's green.
Kermit the Frog would be happy, huh?
Elmo would be sad.
Oh, poor Elmo. Did it move it though? Is it in a slightly different position, or not?
No, seems like it's the same. Let me go back.
So Diego, but
Yeah,
if we
it's
look
in the
at
same position. It's just the color changed.
and so O5, let's see if we can apply our forensic eye to that graph, because if we're doing this with openness, it looks like It looks like it's a little more complex. So it might not just be one variable, but it looks like O5 might be the culprit there, right? Is it sticking out just because it's closest to the perimeter? Or
Hmm.
see, O2, I bet it's O5 and O2 because look at the association between O2 and O5 is positive, and all the other lines going from O2 and O5 to all the other openness items are red. So let's alpha on the openness items, and I bet 2 and 5 both need to be reflected. Don't you think?
Yeah, I'm thinking that A1 is here all the way to the side because it's negative with a lot of the other constructs. Um, so it's the most unlike everything else, but not sure. Maybe it's just there.
I'm I'm amazed that it's not miscategorizing anything, but it's definitely kicking out some items. So can we find the items that it's kicked out? Because I don't see N1. Do you see N1 on there?
Oh yeah, it kicked out some because the UVA thing, it kicked out items that were redundant, that had high local dependency.
Oh,
So if
okay.
we don't run this function, if we just like here, if we just use the BFA like this 1 to 25, you should see all the items.
Okay.
There you go.
So then is one gonna be like plot? Yeah, it's not mischaracterizing anything, which is why I before we drop tonight, I want to see what this looks like. Oh, there you go. So N1 and N2, that's the redundancy. So if you look at how close they are and look at how wide that linkage is. So what is that correlation then? I wonder what the cutoff is. Above zero point 0.7 or
It's this metric that it's using. It's called weighted to topological overlap, and it's
oh
it's
yeah,
on it's this
a weighted
formula.
topological overlap.
I'm not sure what it is, but everything that's above 0.25 uh, gets removed.
Okay. But do you want to just do a bivariate check on that out of curiosity? Like, I wonder what that
The
number is.
N1 and
I'm gonna
N2,
guess I'm gonna guess point 0.8. What do you think that is? N1 and N2?
0.8. Do we make bets?
Yeah, I'm saying point 0.8. What do you think?
um, I'm saying 0.75.
Yeah, I think you're probably right.
So it's gonna be N1 and N2. None of us. 0.7.
Okay. I think that was my first guess. Um, well, let's take a look at unless there's anything else you want to explore with that, Diego. I think we take a look at another data set. I'm just getting the scoring key for you here based on the corrected item totals. Ooh, there's a couple of messed up scales. By messed up, I just mean balanced. There's a lot of reflected items in there. But I'm just mostly curious if this visual method, and again, this kind of, for the purposes of authoring stuff, we're just trying to get a visual here, a diagram that might look neat in a report. But for purposes of just kind of our own dimensional structure curiosity, I'm curious to see if the corrected item total correlation method of reverse constructing or identifying a scoring key is going to match with the visual. I really want to see some of these items mischaracterized. It's like the data's too perfect to come up like this, right? I mean, it's 5. Why is it 5? Why isn't it 6? Why isn't it 4? Why aren't some of these items scattered across different? Doesn't that seem odd to you? Like it's too perfect. It's too good. It's cheated somehow. Do you think it's cheated, Diego? I think it's cheated.
I don't know. The BFI, is it a real data set or is it just
Uh, it,
simulated data set?
it's a real data set. I think it's males and females. I think there's an age range on there too, so it's not students. It's a nice clean data set. So uh, my data is messier. So I think let's try the NEO data, Diego. You'll need HMISC or foreign or something to read in that SPSS file.
Yeah, I got it here.
Okay. So maybe do you want to show what that file looks like in terms of items, and
Yeah.
I can talk a little bit about the structure of it. It should be um, I think that's the IPIP, Diego. Can we get you can do that. That's fine if you want to do the IPIP. There's just a
No, this is
ton
the
of,
Neo. It's the Neo. It's the 122. Um, the IPIP is like 21,000.
oh, okay. I got you. I'm sorry. I didn't see that. You're right. I didn't know I had that many identifiers in there. Um, so the NEO, the five dimensions should be repeated in sequence. So items 1, 5, 11, 15, 21, 25, etc. Those are all one of the five dimensions. 2, 6, 12, 16, 22, 26. So it goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3. So it just keeps repeating. So if Diego does this analysis on item 1 through item 60, what we're looking for is we're looking for 1s and 5s to be grouped. We're looking for 2s and 6s, 3s and 7s, 4s and 8s, and 5s and 0s. Oh, I screwed that up. 1, 6, 2, 7, 3, 8, 4, 9, 5, 0 is what we're looking for in
Okay,
terms of the suffix on the number.
let's do
Numbers
the
don't have
UVA then.
suffixes. UVA?
It's
Wait.
the thing to remove the redundancies.
Oh, I bet we're going to have a lot of redundant on this one.
It's going to be from 3 to 63, right? No, 4. 4 to 63. Oh no, I got an error.
On the UVA?
Oh, it wants it to be a data frame. Okay.
Must be something weird about reading in that SPSS file. You know, I this morning, Diego, I started playing with a different data structure, a different data format that I hadn't come across before. It's a shape file. It's a data file with a shape information in it. Kind of interesting.
Hmm. It doesn't want to read it as a data frame.
Oh, sorry. I'm looking at my stuff, not yours. The UVA doesn't want to work?
Oh. That was my fault, actually. Okay. So now, let's see the Neo UVA. Let's see what items it kept. Okay. So 3 items were very redundant. Let's see if now the plot works. I doubt this is gonna work.
Too many items?
I don't know. It's just how is it gonna know what's conscientiousness? What's
Oh, you mean work in terms of the nice grouping that we saw in the BFI? Yeah, I'm skeptical too. But I think, work in terms of get a picture, I think we'll get a picture.
Oh, we did actually. And I think it might be 5-factor too.
How does it do that? Now, all right, you got to look into this. These guys are pretty bright. What if it only does 5? It always does 5. We should give it a different.
We just create a random data set and feed it.
It was
Yeah,
created
5.
by 5-factor like purists. Like there's only 5. So yeah, we're looking for 1s and 6s to be grouped. We're looking for 2s and 7s. By the second number is what we're talking about. So if we look at the reds, There's a lot of ones and sixes there. There's only
There's not
one.
there's not that many blues. What happened here? There's only four
So,
blues.
so if we did a factor analysis, that's probably going to be our fifth factor. So, a traditional factor analysis goes from strongest to weakest. I'm befuddled that it's cutting off five. Like, really, I did not expect that.
Cutting off five. Where?
That we're getting five. That we're actually.
Oh,
What do you? Why don't you take a subset of that data? What if you just take? Can we do? It's going to be kind of a pain in the butt.
a random subset.
Well, no, not random. What if we just took one of the scales? So can we do? Can we do just 1, 6, 11, 16?
Okay.
I think that's neuroticism if I remember right on the NEO.
Which one was it?
Oh, you're right, because the columns are different. So it'd be 4, 9, 14, 19. No, it's got to be comma because we're gonna have to go. We only want. What I'm saying is, what if we
Oh,
create
yeah.
a data set only with neuroticism items? So 14, 19, 24, 29.
19, 24, 29, like that.
Yeah, you can go all. Why don't you go all the way up to 59?
Oh, wait. 34, 39.
Yeah, I think that's fine to actually prove our point. So that should just be neuroticism items. Looks good. Let's see what this thing does here. If it still gives us 5.
Should I remove redundancies or just go straight to the plot?
I think just go straight to the plot. I do like that remove. That's probably a good. It's probably a good step in kind of data prep and data getting your analyses right. Okay, too. I
Okay.
wonder. Let me see, because I have reverse scored on my reverse scored on that one are 1, 16, 31, and 46. No, so it's not it. I was just wondering if it was going to reflect, if it was going to pick up on that, but it's not.
Let's see what the alpha, what the corrected items are. Wait.
Oh, it's going to be a little different too because I don't know if you have all the items in there. It should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, yeah, you got them all. Should be 1, 16, 31, and 46 is what I got on my end. I don't know. That's a neat thing you came across here, Diego. We're going to have to play around with this a little more, not for authoring purposes, but just kind of us, like learning a new procedure. I'm glad it only came up with 2. I wish we, so, you can do it on you created a smaller object, didn't you? IPIP, or not IPIP. Didn't you create a subset object, Diego, of just neuroticism items?
Oh yeah, I should just use that.
I forgot what I was gonna say. I got on my end. I got 1, 16, 31, 46.
Okay, so item 1 here, item 22. Where's 22?
There's no 22. No. I 1, 16, 31, 46. So it looks like I got the same as what you got.
Oh, 16 is here. Yeah, I thought it was dividing it into like the negative ones and the positive ones.
Right. I was wondering that too with the two different factors that are coming
Well,
up here. Are
30,
there, Diego, for this
31.
procedure, did you read far enough into it to see if there's any sort of follow-up diagnostics other than the visual that we can get a sense
Oh yeah,
of?
yeah, there are.
Okay.
So it does bootstrapping too. Um, uh, Stability of it, which it looks to me like this is eigenvalues. I'm not sure what it is. It also tells you which algorithm it used. So it used lasso algorithm, and it shows the gamma and lambda parameters.
Okay. I mean, I'm impressed that, well, the VFI data is super impressive. There's no misclassifications there at all. But the NEO data, it did a great job with that too. And historically, that's been kind of messy data. I did see a picture, Diego, um, in the source article that I read. It looked like they did a bifactor analysis too. Is there any sort of, and I didn't read it closely enough to understand if that was something that they were comparing against, or if that was something that they did using this procedure. Is there any sort of user control over what it is that's being estimated? So could we actually use this to try to force a bifactor structure? Or is this purely exploratory? It's going to give us just whatever it sees.
I think it's gonna get us whatever it sees.
Yeah.
Here in his example, you can put the keys, this key, but this is only the content of the items. I don't think it does anything to the graph, but I might be wrong. What is this? Yeah, because in the BFI the items are named A1, A2, blah blah blah. So, but in the Neo they're named item 1 to 60. So yeah, it just does an exploratory analysis. It doesn't force anything.
Okay. Huh. Well, yeah, we have to. I mean, if we were going to use this in like a real world application, we'd have to obviously do a little more digging and reading. But it's neat just visually. It's cool. I like the graphs.
Yeah, and it does do additional analysis. I just haven't read into it. I just scanned through it really quick.
Yeah, we're gonna want, we'd want like a goodness of fit kind of thing. Like how much you said there's a kind of strength of weight or reliability kind of chart in there. We'd want probably a number or two associated with that too. Everything's five, 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 five. Okay.
And then dimension stability, I'm not sure what it is. Communities.
Communities or communalities? It says communities?
Communities.
Okay. I don't know what a community is. So, yeah, we'd have to dig into that.
And then these look like, I don't know, eigenvalues. Too high.
Uh,
Too high, right?
the numbers are too small. I can't see it. Are they capped at one?
Yes.
Okay. So those might be communalities, like essentially a R squared of each item with all the other items as predictors. I don't know because I haven't looked at that. So, but neat. I like the visual, Diego. I'm blown away that it came up with five. I want to dig a little further and I want to see how confident it is in those five. And
Want to check on the IPEEP? IPEEP might be too much.
I do. I gotta go, but yeah, let's do it quick. I wanna. I'm curious. So the IPIP is. I think there's some demographics and other stuff in there, Diego. So um, we'll probably have to filter down to just a subset of those
Yep.
items.
Okay, it's taking a while here because it's 21,000 respondents. There we go.
Kicked out a lot. Actually, it's not terrible, is it? For I think there's 300 items in there, so that's
It's not that many.
no.
The graph is gonna look crazy. 300, 300 items, and
Well,
21,000 respondents.
yeah. See if your computer starts smoking. You know,
Mine.
most of these procedures they're done not on the raw data, but on correlation or covariance matrices. So the number of people shouldn't matter. The number of items, yeah, that's a lot. It's too many. We might have to do a subset. Is it thinking?
I think it plotted it, but it's too big, so it's not. It's just a white screen.
Um, we could try just like, 1 through 100 or something. First 100 items maybe instead of all 300. The other
Okay.
thing that I think might be in that file is I think there might be scale scores in there. I'm not sure that that's a raw data file. So if there's scale scores in there, that should come up in your redundant analysis though.
Okay, I think I blew up R. Let me restart it.
We need a bomb. I don't think I have a bomb.
Can't find Uba.
Are you gonna save that script in the live stream repository, Diego?
Um, yeah, if you want
Or is
to.
it? I'm
I mean, all,
kind
the,
of.
all this code is in the website.
Oh, okay. But I mean, you did do some extra with the different data sets. But you're primarily just following um, the UVA items that maybe aren't providing unique information, and then the follow-up exploratory analysis, which is what's the command for that? EGA, just capital
Yep,
E, capital G, capital A.
yep.
And it's still thinking, huh?
There we go.
It came up with 5 again.
Was it 5? Yeah, it's 5. I guess the IP. They're all scattered around.
The Yeah, they're scattered. So and this one isn't. This one doesn't follow the same sequence as the NEO. So it's kind of 1 2 3 4 5 1 2 3 4 5, but then it'll mix it up. It'll go 1 1 2 2 3 4 5 5 5 1. So the key is more important in that one. It's kind of more hidden. So we won't be able to identify numbers in terms of sequence. Oh, six. Okay, I feel better. I came up with a sixth. Wow, that sixth one is pretty big too.
This one, number 4 is only 3 items.
Ashton and Lee, they'd be happy. We came up with a six-factor structure. That's the hexaco with honesty, humility in it. Is that? Yeah. So this is why we need like fit indices, or we need some follow-up. We need to see like what's going on with that three-item factor. Like why, you know, why are they still in there? They must be in there because they're so highly related to each other, and this is probably another reason to do that first step like you did the UVA. Because if we had redundant items, they would identify as just a unique factor themselves, I'm guessing. Because that's what it looks like happened with those three, the 4, 34, and 9.
We can use IPEEP, EGA, and then summary. I think they had the summary here somewhere.
You can expand that object in your
Oh, yeah.
environment, and we could.
It's just summary. Okay. Let's see. Summary, IPEEP.
It isn't a pretty picture though. You can put it up on your refrigerator next to some Millie crayon drawings. There we go. Okay, so again, non non-traditional indices here, but at least we have something that we can go with and report, right?
Edge density. Do you know what that is?
I don't. That's what I mean. These are non-traditional. I don't know what these are, but at least we have some numbers. I still would like. So it's not calling them. It's funny. So community they're using as kind of a placeholder term for scale, dimension, trait, construct, etc. Because those are loaded terms, and so it's talking about groupings. Doesn't want to use the word cluster. Doesn't want to use the word trait. Doesn't want to use the word
Teffy. Maybe Teffy is the fit index in this. See.
Teffy. I don't know. I know they in their article they talked about Bayesian information criterion, the BIC. So
total repeat fit index.
Okay. I would like to see some fit statistics within each of those communities, is what to use their word, communities as well. Each of those 6 clusters. That would for scale development purposes, that'd be something that you'd probably want to see. And they probably have it. We'd have to dig for it. Total entropy, is that what that is?
Yep.
Quantum information theory. That's getting sophisticated.
Well, what's a good Teffy?
I don't. I have no idea.
We have negative 120. Is that good or bad?
A lot of those fit statistics, they don't have sampling distributions associated with them, so it's kind of rules of thumb. So it's not, we don't have probabilities associated with a number. It's just kind of, is it above 0.8? Yes or no? So I don't know if that's the same, but that's kind of characteristic of this realm that we're in right now with dimensionality assessment. Okay, I better get going, Diego. But that's awesome. Thanks for showing us that. That's neat. I wasn't aware that existed before you brought it up.
Yeah.
So.
Yeah, pretty cool.
Okay, thank you. So I will see you on Friday, right?
Yep.
Okay, see you then. All right, good night, everybody.
Have a good night.